My dear students, in continuation of our transportation algorithm, we have begun with northwest corner method, least cost method, then one more Ogel's approximation method, I mean VAM in the previous classes. Let me continue in the same manner regarding one more quite lengthy one, quite enlarged one. It requires some little patience to solve the example, which is known by modified distribution method, that is Moody method. Okay, this method can be applied to transportation tables with initial solution under two cases. Case 1, when there is no degeneracy. What is the meaning of no degeneracy? That is when number of allocated cells is equal to m plus n minus 1. What is the number of allocated cells? We shall see. Okay, then case 2, when there is no degeneracy, that is when number of allocated cells is not equal to m plus n minus 1. When there is degeneracy, that is number of allocated cell is equal to m plus n minus 1. Therefore, when there is no degeneracy means when the number of allocated cells is not equal to m plus n minus 1, where m is the number of rows and n is the number of columns shown in the table. When there is no degeneracy, that is when number of columns is m plus n minus 1, let me consider the same thing with one simple example. The title of the example will be find the initial feasible solution and then optimize by Moody method. Repeat the condition, initial feasible solution. We need to get the solution any one of the previous methods as we have already known. That is either northwest corner method or least count method or least cost method or VAM. The table is already given here. You can see the initial solution obtained by both northwest corner method and the VAM is identical. That is they are same. And the solution table is given by in this manner. We have giving the example from the northwest corner method. That is what the initial approximation will be known by either northwest corner method or VAM. You need to use any one of the method. And in both cases, the total cost will be rupees 830. I think this example is already covered by our previous two methods. I am using the same example with the direct solution. Okay, next. Step-by-step procedure of the Moody method. Step 1. Check for degeneracy. As you have seen in the case of beginning of this condition, here m plus n minus 1 is equal to m is the number of rows, n is the number of columns minus 1. 3 plus 3 minus 1 is equal to 5 and the number of allocated cells is equal to 5. How it is? Refer this table. Allocated cells here 1, 2, 3, 4 and 5. Therefore, these are allocated cells and the remaining are what? They are non-allocated cells. Degeneracy does not exist. Therefore, go to the step 2. Let U1 is equal to row A, U2 is equal to row B, U3 is equal to row 3, row C, V1 is equal to column P, V2 is the column Q and V3 is the column R. You can see from the table. And for all cells, the respective values are C11 is equal to 5, C12 equal to 7 and so on. C33 is equal to 7. The first denote, the number letter will denote the respective row and the second letter will denote the respective column. C will the cell. Okay, C means cell. Therefore, for the unallocated cells, therefore the allocated cells will be what? Here, observe from the table, AR is equal to 8. The position is what? X13. First row, third column. X13 is equal to 8, X21 that is BP is equal to 4, X23 that is BR is equal to 6 and X31 that is CP equal to 6. You can see from the table. Next, step number 3. Consider the column Q which has maximum number of allocations, which is therefore it is 3. Consider the column Q which has maximum number of allocations. Column. In the first column there is only one allocation, in the second column there are 3 and again the third column there is only one allocation. Therefore out of these 3 we shall choose the second one which has maximum number of allocations. Therefore 3. Next, V2 is equal to 0. What is V2 here? V2 is the column, because we are choosing the column Q. Hence, V2 is equal to 0. Refer, I am not taking V2 is equal to 0 directly or arbitrarily. I have chosen V2 is related with the column Q, which has maximum number of allocations. Next, for all allocated cells, we have U1 plus V1 is equal to 5. U1 plus V2 is equal to 7. Here U1 is the first row, V1 is the first column. U1 is the first row, V2 is the second column, U2 is the second row, second column, third row, second column, third row, third column. You can see from the table number of allocated cells. U1 plus V1 equal to 5. Next, U1 plus V2 equal to 7, and so on. You can see here. Therefore, from this table, I am rewriting the table. Next, consider U3 plus V2 is equal to 7. We shall start from here. U3 plus V2 is equal to 7. Why U3 plus V2 equal to 7? Because we have already known V2 is equal to 0. We have already taken. Therefore, to put the value, because we need to find what is U1, what is U2, what is U3 for these cells from this calculation. Therefore, V2 is equal to 0 means what? U3 is equal to 7. Next, consider U2 plus V2 is equal to 4. Again from the table, U2 plus V2 is equal to 4. What is the condition? V2 is already 0, hence U2 is equal to 4. You can see the calculations shown here. Next, step 4. Now compute Cij minus Ui minus Vj for all unallocated cells. My dear students, please refer this very important. Cij, cell, Ui, respective row, Vj, respective column, where each element is greater than 0. Xi is greater than 0 means what? Each element is greater than 0 using the above result. X13. X13 from the table. X13 is what? Non-allocated. We need to consider the non-allocated cell. Therefore, X13 is equal to what? AR from the table. X13, I is equal to 1, J is equal to 3 in Cij minus Ui minus Vj. Therefore, it is what? C13 minus U1 minus V3, and U1 V3 these values are calculated already in the previous condition. I am using the same terms here, substituting 8 minus 7 minus 0. What is C13? C13 is shown here, non-allocated cell. Its value is what? 8. Therefore, it is C13 is 8. 8 minus 7. U1 is equal to 7. Where is U1? U1 is equal to 7 is already given. And V3. What is V3? V3 we have calculated. What is V3 here? V3 is equal to 0. It is already calculated. Hence V3 is equal to 0. Therefore it is 1, which is positive. Then next, one more allocated, X21, non-allocated, X21, using the same fact, I is equal to 2, J is equal to 1, which is also positive. X23, which is also positive. X31, which is also positive. Refer this very important condition. All the non-allocated cells should possess positive values. We shall see from the above calculations that all Cij minus Ui minus Vj values are positive. Refer this very important condition. Hence, solution stage is reached, and the current transportation table gives the optimal solution, that is the allocation with the lower cost. Therefore, the optimal solution is given by 5 into 65, that is the allocated 5 into 65 plus 7 into 5 plus 4 into 30 plus 7 into 7 plus 7 into 43. How much it is? Again it is 830. It means what? The optimal solution is same in case of northwest corner method and Vogel's approximation method, and the present method which is known by Modi method. Okay? Yes, this is the condition. And now we can put one question here. If any one of the result is negative, what happens? We shall see it afterwards. Now, my dear students, just try to solve the example with pen and paper. Do not just read it. Afterwards, I will give one more example to get the solution. Okay? Thank you.